to the PDISCO video summary series for Introductory Statistics, a textbook written for students taking their first university or college level statistics course. Introductory Statistics is a comprehensive resource that includes videos, such as this one, podcasts, virtual tutor e-learning, homework activities with anti-cheat functionality and automated marking, lecture slides, and a lecturer resource manual. Find out more at pedisco.com/intereststats. For now, over to the author.
Hi, I'm Sean Thompson and welcome to the first summary in the PDISCO Introductory Statistics series. In this one, we're just going to go over the basic concepts of statistics. But before we even get into that, we have to ask ourselves, why? Why study statistics? What's our motivation for doing that? Well, a pretty simple motivation is that we're interested in something, and that something can be pretty much anything, and we just want to be able to explain it. Let's take a political example. Let's say there's a federal election coming up between two major rivals, Bill and Bob. And let's say you work on Bob's campaign and Bob is the anxious type. So even though the election's a month away, one day Bob comes up to you and he asks, am I going to do it? Am I going to actually win the election? Well, using statistics, you are going to help answer Bob's question. Now, the name that we give to the thing that we are interested in and would like to explain is the population. So what's Bob's population? Well, let's see. Bob's really interested in all the votes, because if he knows how all the votes are going to go, then he's already answered his question. So Bob's population is a set of all votes. Now, it's all votes across the entire federal election, and that's a rather big population, and Bob's going to want to know as much as he can about it. The things that he does know about it, we call them parameters. So the idea is Bob wants to know the parameters of his population. But if you think about it, and this is kind of the whole idea behind statistics, is Bob's probably not going to know that many parameters because the population is too big. It's too big to look at and analyse and know anything about. So what Bob's probably going to do, if he's smart, is he's probably going to send you out to run a survey. So you might survey, say, 100 people, ask them how they're going to vote. In doing that, you're collecting what we call a sample. Now, a sample is a subset of the population that is looked at and analysed, and we know things about it. And the more we know about it, the more we can try and conclude about the whole population. And in a way, that's our motivation for studying statistics. And in a way, statistics is in two halves. On the one hand, statistics is all about data. It's about collecting and looking at it and analysing data. That's called descriptive statistics. But then there's inferential statistics, which is all about drawing conclusions from the data to the whole population, which is the thing we're interested in after all. Now, we've just used the word data, and it's a word that you've probably heard before, and you're probably quite familiar with it. But what exactly is data? Well, in statistics, data are the observations we make when we go out and collect a sample. Or to be more precise, data are the observed values of the variable that we're looking at. Now, a variable is just any characteristic of interest that can take different values. So Bob's variable would be who are you going to vote for, because that will vary from person to person. So when you go out and run your survey, you're going to ask 100 people who they're going to vote for. You're going to get 100 answers. Those answers, they're your data. So that's data, and there are a lot of different types of data, and this diagram shows the main types that we have. On the left-hand side, we have categorical data, and that's data that can take qualitative options. And on the right-hand side, we have numerical data, which is data that can take quantitative options, which basically means numbers. And categorical data can be measured for a nominal scale, which means that there's no natural order to the different options that the data can take, or it can be measured on an ordinal scale, which means that there is a natural order to the different options. And numerical data can be measured for a discrete variable, which means the different values are countable and counted out, or it can be measured for a continuous variable, which means that the different values exist on an ordered continuous spectrum. Now, to get some practice at remembering these different types of data, let's use the PDISCO e-workbook and have a go at a question. So here we have a question where the North Star Motor Corporation has handed out a survey to its customers. In the survey, they ask two questions, both of which produce categorical data. You're being asked what types of categorical data they are. So we'll submit our answers. The first question produces nominal data, and the second question produces ordinal data. And we submit that. And now we get personalised feedback for our answers and an explanation for the question. So that's data. But how do we get data? How do we collect it? Well, there are two main methods of data collection available for us. There's observational studies and there's experiments. Now, in both methods, we basically get data by observing responses from subjects of the study. But the way the methods differ is in how we treat those subjects. Now, in an observational study, we basically don't treat them, we just observe them. So an observational study could be a survey, for example. Another example, say you're studying blood pressure across the country. Then what you might do is you might go out and collect 100 people and then measure the blood pressure in all of those people. Now, the values that you'd write down, that would be your data. And that would be an observational study because you've just been trying to observe the people. You haven't been trying to affect them or affect their blood pressure. But in an experiment, you are trying to affect the subjects of the study because you're trying to test the effect of one variable on another. So you do provide controlled treatments to the subjects. So if you were testing, for example, the effect of caffeine on blood pressure, then what you might do is go out and collect 100 people, but this time split them into two groups of 50, provide a dose of caffeine to the first group and a placebo to the second, and then measure the blood pressure in everyone and see if there's any difference between the two groups. If there is a difference, you might conclude that caffeine does affect blood pressure. And that's an advantage of experiments over observational studies, is experiments allow you to establish cause and effect relationships. If you are going to run an observational study, well, the first thing you're going to have to do is actually collect a sample. If you want to survey 100 people, well, then you're going to have to go and find 100 people so that you can survey them. And that has to be done correctly. You can't just go and survey your family and friends because your family and friends probably don't represent the entire population that you're trying to explain. And when that happens in general, when the sample that you collect fails to represent the entire population, we call that bias. Now, there's lots of different kinds of bias. There's non-response bias, there's undercoverage, there's non-random sampling. Now, this talk is just a summary. If you want to learn more about those kinds of bias and how to avoid them, you can read about them in the PDISCO Introductory Statistics textbook. Right now, I'll just go over non-random sampling. And that's what I was talking about when I mentioned surveying your family and friends. You aren't allowed to do that. You have to choose the members of the sample from the population in a completely random fashion. Now, the simplest way to do that is to use simple random sampling. That means getting all the members of the population in a big long list and just choosing members from that list on a completely random basis using some sort of random number generator. Now, that method is simple, but it actually is quite time consuming. So we often use variations on simple random sampling. Common variations are systematic sampling, stratified sampling, and cluster sampling. Again, this is just a summary, so if you want to learn more about those sampling techniques, you can read about them in the PDISCO Introductory Statistics textbook. So that's collecting a sample for your observational study. But what about experiments, the other main method of data collection that we have? Well, yes, experiments do have their own considerations because we aren't just observing the subjects in an experiment, we're actually treating them as well. Now, I went over the basic nature of an experiment when I talked about testing the effect of caffeine on blood pressure. So right now, I'll just go over the other main considerations that we have when we're designing an experiment. Firstly, as with a sample, it is absolutely vital that you randomise experiments. So here that means assigning the subjects to the different groups to receive the different treatments in a completely random fashion, otherwise you're going to bias your results again. Secondly, it can be appropriate to block experiments. That's when you think that there are different demographics in the population and in the group of experimental subjects that you think might affect the results of the experiment. So say you think that men and women might naturally have different blood pressures. Well, when testing the effect of caffeine on blood pressure, you might want to actually split men and women up and then actually run separate experiments on the two genders. That way, the effect of gender on blood pressure won't get mixed up with testing the effect of caffeine on blood pressure. And finally, it is also important to use a control group in an experiment. Now, that's what I was talking about earlier when I mentioned giving a placebo to a group. A placebo is a fake dose of a drug, and in general, a control group is a group that receives no treatment or receives a trivial level of treatment. Control groups are important to make sure that the variable that you think is causing an effect is the one that's actually causing it. Say, for example, you look at the group that receives a placebo and they don't have a heightened blood pressure, for example, then if you look to the group that receives caffeine, if they do have a heightened blood pressure, you can be pretty sure that caffeine is the thing causing it. So that's Chapter 1, Introduction to Statistics. The key topics were statistical concepts, data, collecting data, sample design, and experimental design.